Welcome everybody to the next talk. First of all, if you have questions in the question-answer part of the talk, please raise your hand and someone will give you a microphone, and when you have the microphone you can ask the speaker a question. So welcome to the talk, building a cybersecurity operations center for SCADA ICS systems from Shah, Sheikh, and please.
Good evening, everyone. Thank you. So my name is Shah. I'm a senior security consultant working for DTS in Dubai, United Arab Emirates. The topic today is about building a cybersecurity operations center for the SCADA infrastructure and process control networks. Now, how many of you guys actually work or have touched SCADA systems? Excellent. So for some of you guys, there's a few slides which will basically do an introduction. So as an agenda, we're going to be talking about SCADA security, the primer, and the need to build a security operations center, the components of building the SOC and the ecosystems, the importance of actually SIM 2.0, log collection, aggregation, security analytics, and correlation to keep the hackers outside. And then we'll go into specific contextual threat cases and use cases around understanding how SCADA threats actually penetrate into the network. One of the very important parts in building a security operations center is to actually understand and building threat intelligence and early warning detection system, right? Without this, you're not going to be able to effectively respond and have an incident response plan. And we'll also be talking about SCADA SOC processes, procedures, and workflows, right? Without a process, without a procedure, if there is a security breach, nobody knows what to do, nobody knows how to escalate the matter, nobody knows how to isolate or contain the issue. And we'll be talking about building an incident offense management plan and basically talking about SCADA cyber SOC versus the security assurance level. Now, it's an overused terminology. People, process, and technology is paramount to any security assurance within an enterprise environment itself. So SCADA ICS cybersecurity, defense in depth. Why is cybersecurity important in SCADA? SCADA is very different to IT or enterprise, right? SCADA is typically controlling a process. For example, oil and gas production, train railway network systems, etc. So SCADA infrastructure controls the process, right? Human safety is involved. And there's a difference. When we're talking about a web server or an IT system going down, there's an outage to a web application. Whereas when you're talking about SCADA, it is effectively, for example, an HMI that controls the emergency shutdown system. So if the HMI is compromised, your emergency shutdown system can no longer be effective, which could result in human fatality. So there are international standards that govern how SCADA security should be carried out. You have the NERC-CIP, the IEC 62443, and the NIST 7628 for smart grid security. And of course, the most important thing in SCADA is to make sure the plant is safe from production and any intrusion malicious attempts. So typically, this is an overall architecture for a SCADA system. You have your traditional enterprise IT infrastructure, which might be secured by a perimeter firewall, next generation IPS. You might be having network access control, email security appliances, but typically this is the enterprise environment where employees work at the corporate office. Then you have the SCADA plant itself, and usually, typically, there's an air gap. An air gap to ensure traffic between the two networks do not flow. But of course, we've all seen Stuxnet viruses, Dooku Flame, these are all particular malware targeting SCADA systems. So typically, how do attacks come into the SCADA environment? So typically you have the office LAN, which is, again, what I showed previously here. This is the office LAN. Now, in your plant network, you will have a series of machines. And depending on the industry standard that you refer to, this is called level 3, this is called level 2, and this is level 1. So level 3 is where you have the management systems, Active Directory, etc. Then you have level 2, which is basically where you have business process control systems, your OPC servers, your HMIs, etc. These are controlling critical processes. For example, instrumentation devices, sensors, PLCs, RTUs. Now, each of these levels should be segmented, zoned, right? So how do attacks can come in? Misconfigured firewalls, infected laptop from a field engineer walking into the site and connecting his infected laptop into the control network itself. You have unauthorized connections. You have infected remote support, backdoor modems or unauthorized modems, USB sticks, flash drives which are connected into the laptops, which then effectively can penetrate into the network. And then you have third-party issues. So there are many different attack vectors that connect into the SCADA infrastructure itself. And when we're talking about SCADA, it's very different to IT, right? So corporate IT talks about IBM, SAP, Oracle if it's an ERP solution. We're talking about Windows, SharePoint, Active Directory. We're talking about protocols like HTTP, HTTPS, TCP, IP, all right? But when we're talking about SCADA, it's very different. It's no longer Microsoft. We're talking about ABB, Emerson, GE, Honeywell, Siemens. These are manufacturers of control system devices. And also when we're talking about protocols, most of the legacy SCADA systems have migrated from RS-232 into TCP/IP, but they're using specific industrial control protocols. And what are these? So there are things like Modbus, OPC, IEC, right? The 608 protocols, HMI, Fieldbus, BACnet, DNP3. These are all industrial control protocols. And typically what's happened over the last 10 years is that you have serial connections, RS-232, which has been migrated over a TCP/IP stack. And all the insecurities that are from RS-232 has basically evolved into the TCP stack. So if you look at Modbus protocol itself, there's no authentication, there's no integrity and authenticity, right? So anybody can connect using a Modbus communication protocol and change the function of the sensor itself. So why do we need to build a security operations center? Right? If you're talking about your traditional IT infrastructure, you have Active Directory, Exchange systems, you have SharePoint. All of these are generating different type of logs. There's an onslaught of logs that are coming. Firewalls, IPS, antivirus, anti-malware, etc. Millions of logs. And I was having a conversation earlier on about human SIM, right? You need automated tools to be able to understand the thousands of different logs that come in and to contextualize them. Most of the organizations are inadequately prepared for a security breach, right? This is a fact. So when there is a breach, nobody knows what to do. So if you remember back in 2012, there was a Shamoon malware, and that hit Saudi Aramco, which infected 40,000 machines in Saudi Aramco. I was literally physically there, right? And what we saw was machines being switched off because the master boot copy file was deleted from the hard disk, which meant that none of the machines could actually boot up. 40,000 desktops were impacted, right? So it's very important that every organization should have an incident response plan, and a plan that is coordinated, controlled, and effective, and the right individuals are identified. So what is the reason why you need to build a SOC? You need to provide continuous prevention, protection, detection, and response capabilities against threats that basically ensure that remote exploitable vulnerabilities are identified, right? And you may also need to, talk to your departments like computer emergency response teams as well. So what are the key objectives of building a SOC? Manage, coordinate, response to cyber threat incidents. Coordinate with regulatory bodies, right? So if, for example, in Serbia, you have a regulation requirement from the government to be secure, then that is very important that you collaborate. Where we work in Dubai, the national government of UAE has enforced security standards for all the entities, so they have to comply to the cybersecurity laws. If anybody is non-compliant, then they are basically penalized, right? And also one very important, the reason why you build a SOC is you actually build recovery time objectives. So if a system does go down because of security breach, how long do you have before you need to recover that system, right? This is very important because there's obviously business impact. Can the system be down for 4 hours or 4 minutes, right? So building a SOC actually ties in the business processes around real-time recovery time objectives and also your service level agreements. So The ability to automate the requirements to meet compliance, of course, is very important. Ensure change control function is integrated into the SOC, right? So if a firewall administrator is making a firewall policy change, this should be identified through a change request procedure. Right? Build a comprehensive reporting dashboard that is aligned to security metrics, and build a local in-house security incident response team that collaborates with national CERT. And of course, when you're building a security operations center for logging, monitoring, reporting, you need to have the processes that are aligned to this. Without this, it effectively will fail. And when you're building a security operations center, you don't necessarily have to have physical teams. You can have physical teams with the virtual teams, right? So when I'm talking about SCADA, you could have, for example, a field engineer that is having a virtual team respect to a process control engineer. So these are all responsible from a security. Security is not just the responsibility of IT or a particular function, right? It's the responsibility of the entire organization. So what are the key components of a SOC? Real-time monitoring, to collect the logs from the different devices, to correlate the logs. So if a user walks into a site and swipes his RFID card and enters into the site, this should be logged in a SIM. So you can integrate physical access control with logical access control. And of course, what you can do is you can build anomaly rules. For example, somebody entered the site after 7 o'clock. This should never happen. So this can again be a detection tool that there's physical intrusion. Reporting is very important, right? As technical people in the room, we generally forget the oversight, right? So to discuss to management and to basically build a business case, you need to have effective reporting, right, of security incidents. Security incident management is very important. You know, pre and post analysis, root cause identification is very important. As I mentioned to you before, you know, people are the weakest link in security, right, from social engineering aspects. Technology, we all use different technology vendors, firewalls, industrial-grade firewalls, Active Directory, read-only Active Directory, antivirus, data leakage prevention systems, all the different types of security products we can think of. But if you don't have a process that ties everything in together, then it's ineffective. So when we're talking about some core components, and I'm going to be getting to the more interesting part in a short while, but proactive monitoring is important, alert notification is even more important, and being able to correlate the different events is important as well. Now, from a security perspective, how can you be sure that you're meeting the best practice standards? This is where compliance and audit comes in. If you implement security, but you're not following best practices or is international security standard, then there's no guideline to what you're doing. So following industry best practice and then becoming compliant is the best way to move forward. Integrating change management, so any changes done in the infrastructure correlates to actual change that's been made, and then configuration management. So is my Active Directory configured with a minimum security baseline? Are my RTUs, are my OPC servers configured without default passwords? These are all important things to do. Incident response, behavior analysis, and reporting is very important. When we're talking about behavioral analysis, how many of you guys have for example, are managing an enterprise infrastructure or a SCADA infrastructure that has multiple VLANs, different type of network interfaces, controlled by a firewall, and how many of you are doing active profiling? So for example, VLAN 10 is used for web services. Now, if you run NetFlow on web services, then you typically would find web-related traffic. And I should not find, for example, SMB flood. So network profiling is very important. This will help you understand what the network behaves like. So typically, in building a SOC, this is the kind of architecture we're talking about. So you have your perimeter network, whether it's MPLS or VPLS or private links. But this is the corporate IT infrastructure, which then connects to your layer 4 DMZ of the SCADA, which could typically be segmented through a firewall where you have web services running, for example, antivirus update servers and the PI servers. Then you have your layer 3 networks, which are basically SCADA management bus, which is the HMI, the Active Directory, and Microsoft servers with DCS applications running on there, like Siemens, Honeywell, etc. And then you've got your level 2, level 1 devices, which are OPC servers, connecting to your instrumentation devices, sensors, PLCs, RTUs. Above that is your data acquisition layer, which is basically collecting the logs from the different devices and collecting all your logs in a large data warehouse. Above the data layer, you have the data collaboration, security vulnerabilities, and event correlation itself. So typically, you have all the different levels which are sending all your logs to a SIM 2.0. Now, how many of you guys have heard of SIM? All right. So SIM is Security Information Event Management, right? It's a tool that is used to collect all the different logs from the different systems, right? So to ensure auditability, traceability. For example, if you're making a modification on Microsoft Exchange or Active Directory, to be compliant, you need to be able to collect logs, right? So this is the tool that collects the logs from the different devices. But not just, for example, Microsoft infrastructure. It's collecting logs from firewalls, IPS, load balancers, etc. So when building a SOC, you need to, of course, monitor your infrastructure. If you don't monitor your infrastructure, you can't be proactive in doing operations, right? So this is the tool that does the log collection, correlation, analytics, and then you have the component of compliance and management, so policy compliance. Does my Windows server meet my minimum security baseline? Are my GPOs restricted? Are my registry keys restricted? Does it still have default accounts, etc., right? And then what you can do is you can integrate vulnerability management, network monitoring, SNMP, and service desk for ticketing. So when building a SOC or security operations center, you need to have a SIM solution. This is the first and foremost. Typically, what is it? syslog, log files, application log export, and then network behavioral analysis using NetFlow. So all your switches, your routers, firewalls are sending either JFlow, NetFlow, SFlow to the SIM solution so that you can start building network traffic identification. Once I have all the logs and the flows, I can then correlate. I can try to understand, for example, somebody plugged in a USB into the machine, and then there was a propagation of SMB traffic to all the different machines in the same broadcast network. And compliance and management and policy conformance, right? So as I mentioned to you before, you need to follow industry best practice to be compliant. So what are these? ISO 27001 and IEC 62443. How many of you guys have heard of ISO 27001? All right, great. Right. So these are international standards that should be used, right, as a benchmark to be compliant and to give the organization security assurance that they are at least meeting the minimum security baseline. Network security security monitoring, SNMP, link utilization, this is also very important, right? So if an interface goes down, it could impact particular security from a business continuity perspective. And security intelligence, like network forensics, situational awareness, artifacts, capturing packets to be able to reconstruct the packets, etc. So typically what we found, right, and this is our experience working in the UAE, right? So organizations are quite well mature. I'm not sure of the situation within Serbia, but certainly organizations are doing the logging, right? The basic logging, collecting the logs. So if there's a breach, they know why the breach happened, but they can't correlate the different breaches, right? They know if somebody or an administrator logged in and logged out. So basic logging is there. And then you have your traditional vulnerability management software to do scans of the network, identifying missing patches, vulnerabilities, etc. And then you have the network team who's basically monitoring the network, right? SNMP monitoring, link utilization, CPU utilization, etc. Each of the team within an enterprise is working as a silo, independently, right? There's no collaboration, no integration, no communication. So when I'm talking about next generation SOC centers or SNOC centers, we're talking about an integrated workflow. So for example, you have your different devices, Microsoft load balancers, firewalls, switching routers, IPS, system controls, all sending your logs to your SIM 2.0 devices. And then for policy compliance and configuration management, that is being monitored by compliance and monitoring. Now, if there is a particular incident on any one of these devices, the SIM solution will be able to identify based on the use cases that you have defined and can generate the ticket to your service desk, and your service desk will raise a ticket, and based on the process that you have defined, you'll be able to isolate the case because you know exactly which person to call, how to remediate the particular problem. And then, of course, we have vulnerability management, where it's scanning the infrastructure and sending vulnerability scan data back to the SIM 2.0. So, for example, if you have a Microsoft or a Unix system that has not been patched, and the vulnerability scanner is scanning this system through vulnerability management, and there's an attack that's actually targeted towards the system itself, the SIM will be able to correlate the data from the vulnerability management and the attack that has been probably detected by the IPS or antivirus, and correlate these two logs together to be able to say there's been a particular attack itself. So when we're talking about SCADA systems, right, as I mentioned to you before, this is the corporate IT, the SCADA infrastructure. You might have a DMZ, you might have the plant site, you might have remote sites, but what you need to do is you need to think from a defense in depth perspective, right? So having firewall at the corporate level, having a firewall UTM device or industrial grade firewall at the layer 3 level, layer 2 level, implementing endpoint security, not only from an antivirus perspective, but data leakage perspective. Host intrusion prevention is also very important because you can identify the traffic profile that's hitting a particular server or a virtual machine, and based on that profile, all of these logs that are being generated by these different systems are being sent to a centralized SIM solution, which is doing the correlation, analytics, etc. And based on the logs that are received, you can then create incidents that don't match to normal usage. So, it's very important to build security operations center processes. So things like data security monitoring, asset classification, normalization, data at rest, event management, right? So to be able to do comprehensive operations or security operations, you need to know the different type of logs that are, for example, simply generated by Windows machines. You have security logs, you have system logs, you have event logs. Each of these different type of logs generate different type of event IDs. So it's very important that whenever you're, for example, configuring a Cisco switch or a Cisco router to send logs, exactly the type of logs that should be sent to the centralized logging solution. Then incident response practice. As I mentioned to you before, if there is a security incident, you need to understand how to monitor your infrastructure, you need to understand how to escalate the incident and who to do reporting to, and how to carry out the root cause analysis. When you have a security operations center, and we've seen it for large enterprises that they need to have like personnel that's working 24/7 to cover the entire shift. And typically this is very important so that when there is a particular breach, you hand over from one escalation engineer to another, etc. Data recovery procedures, this is also very important, and it should be part of a SOC process, right? If a virtual machine was to be breached, was to be compromised, how can you quickly recover from that particular situation, right? So as I said to you before, defining the recovery time objectives and recovery point objectives are very important, because without this, you will never know from a business impact perspective how quickly you need to be able to recursively go back, bring your backup line, and bring the virtual machine back online. Each different type of security incident should have a different process, right? So for example, an antivirus or a virus outbreak is different to, for example, a DNS cache poisoning or internet misuse or suspicious user activity monitoring. Each one has a different process because each one has a different escalation procedure. Vulnerability management. How often do you scan the DMZ? In the IT infrastructure, you can scan on a regular basis, right? But in the SCADA systems, you cannot just scan in an intrusive way, even in a non-intrusive way. So it has to be controlled. In the SCADA environment, you also have no internet connectivity. So it's impossible to carry out, for example, virus signature patching, etc. So you need to do it in a controlled manner. And of course, as a security operations center, you should be building operating manuals for all the different components that you have within your infrastructure itself. Building security alarms and alert classification is very important, right? So whenever there's a critical alarm, what is the actions that define how to fix those issues? And of course, investing in a security operations center where you're monitoring all the defense capabilities, you need to be able to report back to the management to say these are the different type of attacks that we prevented, and these were the different KPIs. So if there is a virus outbreak, you're reporting to say we contained the virus outbreak within a matter of hours and not days. So when you're building your security operations center, you need to be able to monitor your infrastructure, but you can only monitor what you know. So first of all, you need to start creating a topology of your infrastructure, the location, device type, systems, security zones, web layer, application layer, DMZ layer, or business process control systems layer, IED layer, demarcation points, ingress points. So you might be having different zones in your SCADA systems, and each of these different zones are talking to a high security layer to a low security layer. And this is what we call a conduit, right? So communication between a low security layer to a high security layer should at least be controlled. So typically, this is what a control systems network looks like, right? You have, for example, your SCADA LAN, all right, one single broadcast domain, connected to your SCADA servers, communication networks, application servers, probably a firewall that basically breaks the communication to the office LAN, and then you have an MPLS network that connects to your substation LANs, etc. Right? So, who can identify something unusual here? What's the problem? From a security architecture perspective. Basically, what you find here is that all of these systems are connected to a single VLAN, a single network. There's no segmentation, right? So basically, the notion that you're following is that each of these systems are having the same security zone, same security trust level, which should typically not happen. And this is what we find in SCADA systems. Because it's legacy infrastructure, the system, the PLCs, the RTUs can only talk at the layer 2 level. They can never do routing. So it's very important when you're building a security operations center to understand the architecture of what your infrastructure looks like, whether it's IT or SCADA infrastructure, right? So you start building your different zones. So zone 1 being the corporate network, zone 5, and then basically it's from zone 4, 3, 2, and 1. And typically when you're building a SOC, you need to make sure that your logs from the different devices are being sent to a centralized solution that can identify incidents and attacks. Without this, you're just waiting for the attack to happen, and you're not really understanding how to do root cause or identify what the attack is. So having a defense in depth strategy is very important, right? So as with everything, we start with physical security. This is very important in SCADA, right? Then the network infrastructure, the layer 2, layer 3, layer 4 level, switching, routing, basic firewalling. The IT DMZ, the mission control systems, so beyond the operating system, so hardening the operating system, and then hardening the application itself, all the way up to hardening the PLC units. So typically, when you're securing an architecture or an enterprise environment, you need to understand the communication flows, right? So if you're talking about penetration testers, pen testers or hackers or ethical hackers, they will try to penetrate into a web application, right? To prevent this from happening, one of the things that we would do is to break down the flows. So in this particular case, this is an MPLS network, and you'll have connectivity going through your firewalls, and then to reach to this particular server here. So, right. So in this particular case, you can see the red arrow that connects to the load balancer, which hits a virtual IP, then hits the server itself. So one of the most important things when you're building a security operations center is to actually build security service catalog. And what I mean by this is understand the flows and applications in your infrastructure and design the security around the flows and communication mechanisms. So in this particular case, I know this is a service that is being used by users, and what I will protect this service because this is the communication path. So I will try to harden my routers, the firewall policies, the application delivery control, load balancer, as well as the application itself and the operating system. So if you harden along this process, you can always be sure that you eliminate 95 to 99% of the attacks, because a lot of these attacks are script kiddie-like. The targeted attacks are the sophisticated attacks. So when you're building a security operations center, it's very important to understand assets. What are the assets in the network? So the name, the description, the technical owner or the custodian of the system, and the business owner. This is very important. So one of the things that you can do in identifying assets across your infrastructure is to scan your infrastructure, do a device discovery, fingerprinting, and then start reverse engineering it. Other important things are to build threat cases, right? So for example, if you have a domain controller in your SCADA system, which is controlling your Active Directory domain, and all the Windows servers that you have are part of the domain, securing your domain controller is one of the most important things you can do, or you must do. Any modification to the GPOs can impact all the different domain member servers. So whenever an administrator logs onto the Active Directory and makes a GPO modification, you can use this as a threat case or a use case that should be monitored by a SIM solution. So any modification is immediately reported, right? These are some of the use cases that you can easily carry out. But carrying out, for example, firewall gap analysis, right? These are important tasks to do from a hardening perspective. And when you're building threat cases, you can contextualize it based on a service and a user-centric. So when you're building threat cases, you can base it around operating system, the application itself, the Unix systems, privileged access monitoring. I mean, how often do we find that networks and applications are breached because the IT administrator himself is vulnerable, right? So if I want to attack a particular organization, the first thing I will do is go on LinkedIn, identify the IT administrator that works for that organization, right? Send a phishing email and try to penetrate into the IT administrator because he has privileges to all the systems. And we've seen that. So it's important not only to monitor, non-IT users, but also IT users. So when you're building a security operations center, you must understand the threat, and you must understand how the infrastructure is used from a service point of view, communication protocol perspective, and then build the threat cases around this. So in this particular case, if you look, one particular threat case is with a unique ID which we developed, so multiple logon from a single user from different locations. This is an example, it's a very high-level example, but it's an example where a single user, Shah, has logged in from Dubai and from Serbia, Novi Sad. He cannot be in two locations at the same time. So these are the kind of threat cases that are developed and built into the SIM solution, right? And understanding authentication architecture, for example, is how you build a SOC. So in this particular case, I have an AIX server, IBM AIX server. I have two users, user A and user B. They're both trying to SSH authenticate to the AIX server. So once they authenticate, you'll be able to differentiate user A and user B. But the moment they escalate the privilege to root level, sudo or su minus root, then they both become root, right? They both become root users. So from a SIM or logging perspective, I lose traceability, right? So understanding the authentication mechanism is very important because then you can start introducing additional controls like a third-party software that will basically run session recording. And session recording is then integrated into SIM, so you always maintain traceability. This is an example of a SCADA dashboard, right? So that was developed. So here, for example, you can see some nice graphs, communication within a SCADA environment. And here you'll find we've integrated a Modbus PLC into a SIM solution. So how many of you guys know Modbus protocol? Okay, so the usual hands. All right, so just like in the internet world, we use HTTP. In the SCADA world, we use Modbus, okay? Modbus is a legacy protocol that's insecure, and it's basically, so imagine if this is the machine, this is a human-machine interface, and imagine there's a sensor, and this sensor is moving up and down because it's controlling the flow of oil or gas through the pipeline. And this is a sensor that is monitoring the cubic meters of gas that is being supplied. Now this machine is doing remote telemetry to this sensor over TCP/IP and controlling the movement of the sensor, right? Now this communication protocol typically is Modbus. In Modbus, this machine can read the registry values, which means tell me that the sensor is at this level or it's at this level. The machine can also write to the register, means modify. Okay? So in a security operations center, if I modify the particular movement of a sensor, this means impact in revenue, impact in production, etc. Right? Shut it down. No oil flow. So it's very important that you understand these communication protocols and build this into your operation center. And in this example, you can see, for example, a new connection has been established on Modbus, which means that another machine is trying to connect and trying to modify registry values. Also, one of the things that I mentioned before is profiling a network, right? In a SCADA environment, you will never see public IP addresses. In a SCADA environment, you should never see public IP addresses because it's never connected to the internet. In this example, a field engineer has connected his machine to the network, and because he's got, he's got all sorts of things configured on his laptop, it's immediately making a call to a server in the US. The SIM solution picks it up because the firewall is reporting it or through NetFlow, and immediately you identify this as a suspicious activity. One of the things that you can do in your organization, right, when you're building a SOC, is you can have offense management. So for example, in your organization, just like you have system devices and host names, you can have incident host names as well. Building workflows for security investigations is very important, right? So all the different logs are coming into the tool. One of the first things you identify is if it's a false positive or a false negative, right? Once you identify it's a false positive, then who is the system owner, containing the issue, reporting the issue, making sure it doesn't happen again. Other things that are interesting to do is building your own intranet page, right? And this is quite handy because if you're managing a large enterprise environment, you can build your own intranet page and build the threat cases. So in this particular case, I don't know if you know RSA Authentication Manager. Anybody knows RSA Authentication Manager? But this is the two-factor authentication key fob, right? It's a one-time password. Now, imagine I'm an employee of an organization and I have the key fob and I leave and I'm terminated. So the IT administrator has disabled that particular key fob. But from home, he's still trying. So in the case of in this example, unauthorized user trying to authenticate with expired or disabled token. In your SOC center, you will get this appearing, AAA RSA 003. Immediately you take this, put it into your portal, and you know the reason why this happened, how to investigate, who to call, what is the issue. So you know you have a coordinated plan when it comes to incident response. All right? And finally, building security assurance level is very important. So those who work in SCADA infrastructure, you have basically 7 functional requirements. Access control, so users connecting onto the network, users authenticating, use control, data integrity, confidentiality, restricting data flows using firewalls, timely response to an event, which is basically a security operations center, and resource availability. I'm not going to talk too much about this because there's only a few guys that are in SCADA itself. But basically, the most important thing is that whenever you're trying to secure an infrastructure, you need to understand where you are, right? Build the controls around it and build operations around it, because there's no point having an infrastructure. So if you're working for a bank, a government entity, you need to secure the enterprise environment, right? And there's no point building all the security and you're not monitoring, logging it, doing auditability, and being able to do investigation if there is a breach. right? So logging, monitoring, doing security operation is just as important, if not as important, as building a secure infrastructure. Thank you very much for your time. If there's any questions, then I'd be happy to answer them. For the hands that were raised.
Hello?
Hello.
Right. So I actually did work in a SOC in previous company, and one of the problems that I can see with your design is you haven't looked at the people, because the SOC is an entry-level position, and so you have a lot of turnover in a SOC. So if you are very skilled, you're probably going to move up to a higher position. So what sort of remedy do you have to keep people in a SOC? And my ultimate thing of the question is, there should be a career in a SOC.
Yeah, sure. I mean, typically...
But there isn't.
Well, I agree with you, but you have to remember that definitely there's a high churn rate, right, in SOC centers, and you do start off with entry level. But typically what we found is that you have level 1 SOC engineers or analysts, level 2, level 3, and that's how the organization can be split. Again, I'm talking about large organizations that have a huge infrastructure to manage. They have 24/7 defense capability monitoring. This is more of an organizational issue, But certainly, from a people's perspective, they need to understand what is a SOC. At the end, as I mentioned, SOC I don't think is a responsibility of security or IT, right? It's the responsibility of the entire organization. And that's how I see it. And we've seen successful implementation of SOCs because you need HR process, you need finance process to be integrated into SOC. If somebody leaves, it's a HR and an IT issue, right? Which means that they have to work together. All right, so thank you very much for your time.